Hello. If you're watching this, I suspect that your truck is doing what my truck is doing, which is driving all the way across my custom design bridge all by myself. Pretty exciting. Now what I'm going to do is stop the truck right in the middle of the bridge, because we're going to do some analysis in a moment. But first we need to record some details about our design. The first thing we're going to write down is the iteration count. And this tells us how many load tests were done to get to the point that we're at now with a working bridge. So that's for question number 1 for design 1 on your worksheet. I'm going to put in 10, you'll put in whatever you have. The next question, number 2, how many members did you use? Well, if we click on this report here, or table of all of our results, we can see that I have 31 members altogether, and you may need to scroll down if you've got a scroll bar to see everything. And we get some ideas here about how strong each piece is versus the amount of force that's being applied to it. So for instance, if I look at the first piece here, first member, there's no compression force, and the compression strength is fairly high. That is overbuilt for compression. If we take a look at the tension force, it's again very small compared to the tension strength of that member. So we can see that by comparing the two numbers that our bridge is very overbuilt, which is good for safety, but we could probably knock it down a bit and still have a safe bridge. Because in most cases, our strength far outnumbers the force. Let's write down 31 for the number of members at any rate. And then the final cost. So I have $490,149.35 being the cost for this bridge, which isn't surprising from what we saw on the table and how overbuilt it is. So we can certainly make a lot of these members smaller. And if we take a look at the members, we want to look at the ones that are the lightest colors, which is almost all of them in this case. Just these two bottom ones have any kind of real color to them. So they have a little bit of stress on them. Everything else, almost nothing. So we can reduce the size of all these other members and reduce our cost. So let's go back to the drawing board and we'll do that. So I'm actually just going to, I think, select all of them because they're all overbuilt. I'm going to shrink them all down to 180. And you may have a different number. I kind of overbuilt it on purpose just to make sure that I got it working. But whatever number you've got, reduce the ones that you can. Now certainly in the truss, and I'm going to hold down the control key here so I can multiple select my members by clicking on them. In the truss here, I know that I can certainly reduce them even further than that. Actually, why don't I just select them all, and then I'm going to hold down the control key and deselect the two, well, these support ones I'll leave. But everything else I'm going to reduce quite a bit more. I'm going to take a dare and go down to 150. And let's see what that does. If we take a look at our price, we've gone down a fair amount just by doing that little bit of reduction. So we should see some darker colors happening. And we do. The pieces here, we can certainly reduce some more. And the W in the middle, we can definitely reduce some more. So I'm going to hold down the control key again and just turn off some of the ones that were darker. We want the W, we don't want those ones we're getting red, so we'll keep those. And I think we can probably reduce the rest. So let's go down 2 more and see what happens, because look at our price, almost $100,000 cheaper already. And we'll see if that does the trick. Oh, good, good, good. Yes, see, we get nice dark colors. It means we're at the limit of our materials, but we still have a working bridge. All right, back to the drawing board, and I could probably start reducing these two. They were pretty light, and so on. Now, all we've been doing is reducing the size, but you can also change whether that member is solid or hollow. Because remember, hollow is more flexible and works better in tension, but not so much in compression. So where your members are in tension, maybe they should be hollow. And in compression, like our column full of sand, maybe they should be solid. So you can play with that. You can also play with the materials. Carbon steel is the cheapest, but the weakest. Next in line is the high-strength low alloy steel. And then even stronger, but more expensive, is the quenched and tempered steel. So by making combinations of material, solid and hollow, and size, you can come up with a bridge that can approach another $100,000 off of this price. It has been done. So that's your goal. Make your bridge as cheap as you can. Another thing you might be able to do is remove pieces. Now, especially if you had built above the bridge, let's say with something along the lines of this, it's definitely overkill. This particular bridge is supported underneath. We can see that by the pier, that it's a below structure truss. So if you have anything on top, it's totally extra and it's just adding weight and expense. So I would highly suggest removing any pieces that are above the bridge. But also, you may have extra pieces that are doing, funny things like this. That if you've made them thick enough and with extra pieces, those too could be removed and make a simpler bridge. Remember, the fewer the pieces, the less expensive it's going to be. That's really what's driving up the cost, are the members. So the fewer the better. I have 31. And it works. Could I do it with less? I'm not sure, but maybe. I could try maybe removing, these two joints and seeing if I could do it with just kind of one in the middle. Could I do it like that? Good question. We'd have to try that out. But now I'm down to 29, so go for it. And when you still have a working bridge and you don't think you can make it any cheaper, watch the next movie.